Okay. Okay, expanding these. Ava, what'd you get for number one? Let's hear. What'd you get for number one?
Oh, I got x squared plus 6x.
Okay, were there any steps in between?
No.
I mean, well, it's good. Yeah, there shouldn't be steps in between.
We
Okay.
must like solve it or like factor in more.
Yeah, when it says expand, it's hard to explain what that means. It just means like do the square thing. If it says factor it, it's already factored. This is x plus 3 times x plus 3. So it's in factored form. You might be tempted to go backwards, but just to be clear on what I mean when I say expand, just means that make that square bigger. And I swear, if you do this, when I say expand, I will laugh as I give you 0 on the grade. I get the joke. Do you get it?
Yeah.
It's cute. It's expanded, but that algebraically expanded. Sheesh. Crazy kids. Number 2. Baron. Yeah, okay, thank you very much. Brandon.
4x squared plus 20xy plus 25y.
Plus what? 25y squared, thank you. And finalmente, Chloe.
I got 25m squared minus 80m plus 64.
Plus 64 n squared, you said? Okay. Any questions? Please show me how many seconds each one should have done approximately. How many seconds each one it should have take you to do? I think I left out a word. Hopefully under 10 seconds. Maybe the writing slowed you down in the process. If you did it like this, and if you did this, that's not wrong. You could distribute, but please make sure you're using the convention. An important tool for this class that we know a plus b quantity squared is equal to a squared plus 2ab plus b squared. I wanted to use that at the appropriate time, just like here. And we know that a minus b quantity squared is equal to a squared minus 2ab plus b squared. Essential tool. Did y'all use that? Tell the truth. Did you use it?
Yeah.
Okay. If you didn't use it, make sure you use it next time. Please, or please, just your ways. Okay, let's do the packet today. This right? 1.5. That is 1.4, so it will very likely have word problems. 1.4? It's 1.3, excuse me. And the last 2 days plus today. Definition of a quadratic equation. Sasha, ready for this? Let's buckle up. That'd be amazing. When you hear the word quadratic in algebra, what number should you be thinking of? Would you please hold up the number you should be thinking of when you hear the word quadratic? Check in with your neighbor and see what they're thinking. What number? So, would like to tell us what number should we be thinking of when you see the word quadratic? Yeah, Baron, what's your Hey, let's were you raising your hand? Oh, I thought you were. Well, I think all quadratics have numbers squared. Are we good with that? That's exactly what I was looking for. And you may be thinking quadrilateral, which I know it has 4 sides, or quadrinomial, which there's no such thing. But if there were, it would have 4 terms. So quad, normally I know means 4, but in mathematics, quadratic is 2x squared. So it's any equation with an x squared term. And you know what an equation is. The essential ingredient of an equation is an equal sign. So definition of quadratic equation, any equation that can be written in the form
ax squared plus bx plus c equals
equals 0. It can be written in that form, so a quadratic equation. And most importantly, a cannot equal 0. If it did equal 0, what kind of equation would we have? It would be linear. I don't want to be any exponent. Remember the terms that we talked about? This is a quadratic term. This is a linear term. And what was this called? The constant. They all do have coefficients. Okay, so if it can be written in another form, then that's not quadratic. That would be, you know what it's called if it's to the third power? It is the third degree equation, but there's a name. Oh, that's a good guess. Like Tetris, kind of. It's cubic, a cubic equation. B.
Four goes to.
Quadratic. Just kidding. A quadratic is second. A quartic is fourth degree. Fifth degree. What is it? Oh, that's a good guess. Quintic or quintic. But let's focus on quadratic because that's all that we're going to be doing now. The second degree equations. So there are some principles you have to know. The main thing you have to know is what are the next two letters? Z. No, P. No, ZPP. ZPP stands for zero product property. Has anyone heard of this? ZPP? Zero product property? If you haven't heard of it, that's okay. You know it. I'm sure you know it. It says that if A times B equals 0, then either A equals 0 or B equals 0. What that must be true, right? As opposed to like if A times B equals 5, we have no idea what either one of these could be. But if A times B equals 0, then A is equal to 0 and or B is equal to 0. We normally say or B is equal to 0. That's intuitive, isn't it? And you know how to multiply 0, ZPP. So we use that a lot, and I'm sure you've used it in the past, used it but without labeling it. So solve by factoring. I'm gonna underline that factoring. That is the main way that you are going to be solving quadratic equations. And how do you know it's quadratic? Because of the number 2 as an exponent, of course. So we factor the left side. How do we factor that? You notice that there's a greatest common factor of 2x, factor that out. So 2x times 2x minus 1 equals 0. You see that we have use ZPP? Oh yeah. Something times something equals 0. So either 2x equals 0 or 2x minus 1 equals 0. And I think this part is not new for you. This should be very comfortable. But maybe it's just a name, I think that may be new. So x equals 0 or x equals 1/2. Yeah. Yeah. And technically, this really is kind of silly. We have 2x equals 0. We have 2 times something times something equals 0. X could be equal to 0. So immediately you don't have to say 2x is equal to 0. So it's up to you though. So B, you might be tempted to divide by 3x, but notice it's quadratic. Please don't ever divide by a variable. Instead, let's set it equal to 0 so we could use ZPP. Are you down with ZPP? Okay, I hope so. So 3x squared minus 9x equals 0. I'll let you finish that. I'll let you finish C and D too.
1,001 seconds, neighbor makes sure they're part. We'll be calling on 3 people to help you with these. I'm gonna call someone for B really quick to make sure we're on the same page. Nia, did you get B already? Oh, I'm sorry.
Nia L, I should say, not. Can you talk me through it, please? Good. Three x times x minus. Let's take a look at that. Is that equivalent to what we started with? Oh, x minus, thank you. Okay. Okay. Perfect. Are we good with this, everybody? Let's just check. How can we check to see if this is right? Let's plug into the original. Please always plug in the original, just in case you messed up on the very first step. Take you see 9.3 Thank you. Let's make sure you're okay with. Has anyone finished C? First thing you did, of course, was move the 4 because we'd like to have that 0, so we could use ZPP. Okay, so and just I'm not going to finish this. I am going to call on someone to help, but just you got to factor that. So make sure you've done that. I think another maybe a minute. I would like to call on a couple students. Is it time? Are you ready? If you need some help, I'll help you through it. Ivy, could you help us with C, please? 2x minus 8 equals 0. Okay, just a minute. Let's get you. It's true that these are equivalent.
Oh, I mean, if you are.
If I look like 2x and 2x, like
Okay, so it seems like there's maybe a little adjustment you still have to do for that second
that
one.
you use for factoring. But let's just check to make sure, and you said x plus 4, x minus 4. Let's check it. Is this true? Is it factored correctly?
This is a tough one to fact. Here, square, okay, we did that for the last term, here, we x minus 4, x minus.
Now, if you had a hard time doing that, please put a star by it and say, get help factoring quadratic expressions or something like that. Like that's gonna be essential for you. Just get help, and that's a mental note you have to do, and actually physically get help. Like, come to me. I'm not gonna come to you. It's your job to come to me, and my job to help you if you ask for it. Okay, Ivy, I'm sorry to interrupt you. Flo, could you help us out finishing this up? Where'd that come from? How do you know that? What 3 letters let us know that? Okay, and then from there you said that x equals 1/2 and x equals -4. Would you all be comfortable going from here to here and from here to here? You may if you like. Just be careful. Yes, yeah.
Like you need this stuff. It's really nice to have this stuff, but if you want to skip this for just, for something, you know, skip that equal there, equal there.
Yes.
Do you want us to write it and choose different things like x equals 1/2 and x equals, what are you starting with 1/2?
Good point. That's fine, like that. It's okay.
Yeah, if you go from here to
Here, I'm okay with that, but if you go from here to here, I have a big problem with that. You see the difference? All right, you can't just give me the answer. So factored form, and then if you want to bypass the ZPP work, I'll allow it. Okay, next. Ivy, thank you so much. We have Sophia. Can you help us with D? Step number 1. What should we do first?
So I
So we made 0 equals 2x squared. Okay. Now, Sophia, I'm gonna stop you here. That this is right. But it's difficult to factor in the leading coefficient. It's gonna get too crazy. You have to struggle with it. It's a problem. Right. So rather than doing the 2x squared for the right versus everything else, to left. Please make a mental note of that. We want the leading coefficient to be positive. It's much easier to factor. Yes, Mia, you. Or you could do that. Yeah. So you move it to the right and then factor out the -1. Good idea. Yeah, if you start with a negative leading coefficient, then you could do that. So you should have gotten 2x squared, I guess, plus x minus 1 in your calculator. Is that inside your parentheses? With each box. Okay, are you okay talking this one? Yeah, there's a trick where the number is going to multiply to not 2x squared, but 2 times -1, -2, then add to 1. Have I told you about this one? We take the product of the first and last, in that middle term. So of course, the two numbers are 2 and -1. So what do we do with that? Do you remember? Am I okay grouping it like this? Yeah. Okay. So factor out the 2x, leaving us with plus one, and then from these two, you're gonna factor out -1, good. Give us with x. There we go. Very nice. So x equals. One. Are we good? Nicely done. Okay, moving on. Square root property. Once square is isolated, then it can be, then not it can be, then you can take the square root. Square root of both sides. Once square is isolated, then you can take the square root of both sides. You like square roots? You hate square roots? Well, those of you who hate this, you're gonna hate this process. So I'm sorry, but I think square roots are wonderful. So I really like this. Just remember that anytime you take the square root of an unknown, you're gonna have how many square roots? R2. Remember? Yeah, plus or minus. Remember to include both square roots. If appropriate. Do all numbers have 2 square roots? There's one number that doesn't have 2 square roots. That number is 0. The square root of 0 is, please don't tell me plus or minus 0. That doesn't make any sense at all. Square root of 0 is just 0. But there are 2 square roots of 4, plus or minus 2, of course. So let's see how this works.
And that's like, right, the negative square root.
Oh, yes, exactly. It could be plus or minus I. Is that what you mean? Plus or minus I. Well, let's cross that bridge when we get there. I love that question. Yeah, thinking ahead. So for square roots, we're not going to use VPP. We're going to isolate the squared quantity. In other words, first step is get over to the other side. 3x squared equals 15. Have I isolated the square? Now I'm going to divide by 3. X squared equals 5. And now that it's isolated, we take the square root. I'm not actually going to put physical square root over it. I'm just going to notice when I take the square root of x squared, I'm left with x. Take the square root of 5. There are 2 answers, plus or minus square root of 5. Done. So by that same token, are we okay if I just go to x squared equals negative 25/9? Is that comfortable? Okay. You can go in 2 steps if you like. Okay, we see x squared equals negative. There's no way to do this problem, is there? Oh, but there is. We have a tool now. We have imaginary numbers. Go ahead and finish this problem. Check to see if your neighbor got the same thing you did. Okay. Is this a pretty good idea? For me to change this to decimal? It's completely unhelpful. Please don't just automatically try to change things to decimals. Who can help me with this? I'm gonna take a true volunteer. Baron for 300.
Cool. So you have to subtract 25 on both sides, and you divide x out by
I like it. Okay.
and then you have, and then you can square root both sides, and you have x equals the root of negative 25 nines. And then you can.
Negative 25 nines, right? Negative 25
Yeah,
nines.
and then negative 25 nines. Square root is just the same as 25 nines. If you simplify 5 squared.
These big picture. No denying it. Is that comfortable? No? A little bit? Hopefully. Any questions? Okay. Now C, this is where some people start going wrong. And with their best intentions, they think back to the warm-up and they say, Mr. Lieberman told me, I know how to do this problem. I can expand it to x squared minus 4x plus 4. But hold your horses, folks. Western day. We're not going to do that. Why not? Discuss. What's another option? Do you see it? Do you see the beauty? It really is a gorgeous process, if you see it. Okay, I need a volunteer to help us through this next process. Please help me. Someone whose name doesn't rhyme with Schmerman. Anybody else? Okay, Baron for 400. See why I have the popsicle stick?
So you have x minus square root both sides, because the square is technically isolated, and you
Okay.
have x minus b is root 6. You add
Wait, just positive root six?
plus or minus root 6.
Just a minute. Are we okay with that? Are we? It's so yeah. The path to isolating the x is quick and last step.
And you add 2 plus or minus root 6.
Oh, that was some swag right there. I like that. Yeah, when you have that plus or minus and you're moving stuff to the other side, pick it in front. So I do want to see 2 plus or minus square root of 6. Instead of plus or minus 6 plus 2, we want that 2 just in front for good habits. And the reason for that is if you're doing the addition, think about on the number line. If you go to 2 on the number line and you add square root of 6, subtract square root of 6 from that number, you can have from that. But that is those are two different solutions. Give in to finish D. I will call on someone. Help us out with D. If I gave it done. You know. No danger of being called now. Do I need to come? Anyway. So there's a neighbor. You're done. What is that? We ready? Ready or not? Here we go. Priscilla, can you help us out with this one, please? Yes, step by step. Okay. Just positive I right 11? Remember, every number has 2 square roots. Yes, we need plus or minus. Oh, so you put the I in front. Ah, not a risk taker. I don't blame you one bit. Okay, are you done?
Um,
Are we good?
If you have
Nicely done.
root 11,
Mhm.
or root negative 11, is that not 11?
It is. Root 11, I. So another way to write this, acceptable way to write this would be plus or minus root 11 times I. Just make sure that I is on the outside of the radical. And don't play with fire there. Do it right. Are we comfortable? Okay, when I continue speaking in about, sorry, at 2:29, have your seatbelts on, because things are about to go crazy. Yeah, in a good way.
Good. We're going.
Good intuition.
these are confusing.
29, so you have under 2 minutes. You gotta start quick if you wanna go anywhere with your answer. Thank you for being conscientious, though. Was there a line to make it? Easily. Wow. Wow, that's true. Hey, thank y'all for being back in time. I appreciate it. Let's get started. Completing the square. Do these three words sound familiar in this order? Completing the square. Have you done this before? Okay, so what this does, I'm gonna look back at the warm-up for just a minute. You don't have to look back in your notes, but what this does is it asks the question. It gives you a partial trinomial, like for number 1. Erases if 9. And then it says, what number do you have to add to this to make this perfect square trinomial? What number is that? Plus 10, plus 3, but we already know that it's plus 9. The question is how, without having seen this problem, how do we get it to go from this to 9? And while we're at it, the same kind of thing down here. Right now, we know that if we added 25 to this, it would be a perfect square binomial. Because it would be x minus 5 squared. If I say something like plus 24 or plus 3 is not a perfect square. So my question is, how do you go from the 6 to the 9? Like, how can you just kind of organically make that happen? How do you go from that 10 to the 25? And there is a mathematical process. You understand the question that I'm asking? If I give that number 1 there, how do you know? Oh, that's what the 9. How do you know that? Let's check in with the neighbor. There's only the 2 here. think I heard it. I think I heard it. Would like to show us the pattern. Someone who's not in the back row behind Lily. Yes, Dylan. Oh, we have another volunteer. One half. What do you mean one half beats? So specifically, like, what would we do if that's six? You think you cut it in half and then. I was good with that. Would you like both? Yeah, but does that work for three? Does that work for three? If it doesn't work for three, it only works, and that's exactly what I'm looking for, it only works in one special. When the leading coefficient is. Otherwise. Complete. So let's synthesize this. Dylan, thank you. Very nice. Who else knows that same pattern? Is that what you're thinking? Cut it in half, square it. Yeah. Yeah, I don't want to complicate things, so let's say that the leading coefficient always must be one. So let's formalize this. If you have x squared plus bx, you can complete the square by adding, it's always adding. I only said to take half of that b. So we're going to take that b, cut it in half, and then square it. So, and Baron, thank you for pointing this out. Note, leading coefficient must be none other than the number 1 for this process to work. So Baron, you're right. There's got to be another way to complete the square for other cases, but we're going to keep it simple with it. And that's the scope of all high school math classes. There's always going to be that leading coefficient is 1. So I'm not going to do that first one because you already know the answer. I mean, we just talked about that. If we have x squared plus 8x, we check in with your neighbor to see what you add to that. It completes the square. One, two, three. 1, 2, 3. Are we good with that 16? You take the 8, cut it in half, right? Divide by 2, and then square it. So we're adding 16. So anytime you do this, I also want you to write this as the square of a binomial. In other words, I want you to rewrite it like this. What's going to go inside? X plus 4. Yeah? Let's do another one before we go on to x minus 5. Let's do a x squared minus 10x. Can you please complete that square? And I'll give you another one. X squared plus 18x. Please complete both of these and write them as the square of a binomial. Like when you're done with those two others I've just given you, do not move on to B yet. I'm going to call on a couple people for this. You're completing the square and you're rewriting it as a square of a binomial. So let's see what the following person has to say about it. Ryan, can you help us out with this one? Okay, we're able to rewrite this as a square of binomial. Does he speak the truth? Nice, you're getting snaps and everything. All right, thank you. For the next one. Emma, we miss you. Someone else. Dylan. You help us out with that last one. What are we adding to it? Okay. And then we can rewrite that out. X what? That's plus 9 squared. Does you speak the truth?
Yeah.
Fantastic. So I hope that this has been pleasant so far. I love completing the square personally. Such a simple process. And it's not like I go out and join the completing the square club, but it's not a painful project to do. But if you want to make the completing the square club, I'm available to be a sponsor. B, you see the difference here? You see why this might be a little bit of a problem? The biggest problem is that high school students are stuck in decimal land. Simpler than that, half of 5 is 5 halves. Does that make sense? 5 over 2. You see how that's a little bit easier to square than 2.5? They're both right, but it's just keep it in fraction land when you're completing the square. So yes, we're gonna add 25 over 4. All right, so the thought process was take that 5, divide it by 2, and then square it. That's where the 25 fourths came from. It shouldn't be a tremendous strain on your brain unless you have a trouble with 5 squared. So rewriting this as a perfect square, it's going to be x. Oh, actually, don't call it. I'll just write it quietly and then show your neighbor and see if you got the same thing they did. Keep it in fraction land. Or fraction bill. So x minus, what is it, everybody? 5,000. Are we good with that? Let's check. If we're going the other direction, you know how to expand that with x squared in the first term, 25 goes to the last term, that middle term, you're just taking this times this and then double. So 5 times x times 2, 5x, all is good in the world. I know it's exciting. Did you finish C already? I'll call in someone to help us out with this one. I would like to call on someone, so please make sure you've checked on someone on your. I'm gonna put everybody back in the cup, so skipping anybody. I'm sorry to the 4 people who weren't called yet. I want to mix this up just a little bit. You want to get you too complacent. Okay. You ready? Yeah, exactly. And I want you to rewrite it as a square of a binomial. Okay, 10 seconds, I'll call on someone. So a little bit of discussion. I don't want to interrupt the discussion. Okay, here we go. I'm gonna have to include last names for both Mia and Nia. Nia, could you help me out with this, please? Okay. Okay. Is that true? Is this 1/9? Nice. So you're adding 1/9? Any questions so far? Okay, and rewriting this as a perfect square. Did you get this already? Are we good? Nice. Very nicely done. Also hope it makes sense to happen 2/3 in one place, right? So how do you get it done? You get that one, get it spraying, get that one in. Okay, so there you go. Complete the square. I hope you're a fan. I'm selling t-shirts after class. Hey, solve each quadratic by completing the square. Oh man. I am so jealous of you all seeing this for the first time. Take a mental image of just what's happening right now. Life is good. I'm not going to use ZPP because that means I'd be solving by factoring, right? By definition, A times B equals C. This equals 0. This is telling me to use completing the square. So anything without an X, say bye-bye to that one side. In other words, I'm just going to subtract 5 from both sides. And also I'm going to leave a space. I wonder what I'm leaving that space for. So I can complete the square. What am I adding to the left side? It's an equation though, so if I add it to the left, I have to add it to the right side. So plus 9, plus 9. Do you see the beauty? Do you see what's about to happen? I'll let you talk it out, work it out, and then talk it out. Okay, I'm gonna take a true volunteer. Someone who hasn't given us an answer yet today. By volunteering, anyway. I don't. Would someone like to share with us? You can't volunteer someone else. That's just not nice. That's my job. Anyone want to give it a shot? No? No? Of course, the left side we're going to rewrite as x minus 3 quantity squared. The right side we're going to rewrite as 4. Good. And now should I expand? That'd be going backwards and forwards. Next step, would you show me in gestures what to do next? I see it. I see. I'm just looking for this, right? Take the square root of both sides. We have a square that's isolated. Take the square root of both sides. That leaves us with x minus 3 equals, be careful, 2 of them, plus or minus 2. I'm going to rewrite this as x equals 3 plus or minus 2. You see how these are two easy problems to do in your head now? 3 plus 2, 3 minus 2 gives us x equals 5 and 1. Was that pleasant? I hope so. I'll give you a minute to try the next one. I will be calling on someone. Oh, I'm not the universe will be calling on someone. Tell me that get it wrong. May not be as clean as the last one, but it's still valid. You check with your neighbor. You do so when you're done, or if you're stuck. Ready? Ready? Ready or not? Brandon, can you help us out with this, please? Before you move on, are we okay with this? Do you have to leave a gap? It's easier. Think ahead. If your process is completing a square, you need a space for that. You need a space for the number. Actually, put in space on. Keep on going. Okay. Okay,
So that's what it's for, at the 4.5.
I want you to tell me about the left side.
So that was, no, we factor that out.
Okay, nice.
And then the square root of 5. So you get out, but it's 3 is ultimately square root of 5.
Does 5 really have 2 square roots? Yeah, all numbers have 2 square roots except 0. So I'm just checking. But yeah, you were correct with what you said in the beginning. Okay.
And then we just go back to F.
Thank you for inserting that -2 in before the plus or minus. Are we good? Brandon, another fantastic job. Thank you so much. Did anyone have a matching answer already? Okay. That's good of you. Can I answer any questions about this? Okay, moving on. The question, even calculus students mess up here. They say, okay, I'm gonna take half of that -6. Square it. And why can't we take half of that -6? Yes, Ava.
Or one.
Which coefficient? Leading coefficient is not 1, right? That 9 is a problem. What do you do when that 9 is a problem like this? You take matters into your own hands. Divide by 9. We could do that because it's an equation, and you can do whatever you want to one side as long as you do it to the other side. So let's divide everything by 9. I'll do just one piece at a time. X squared minus 6/9. X minus 4/9 equal, what is 0/9? Oh yeah, that's 0. Okay. The 6/9 is a little bit strange, don't you think? 2/3. Let's rewrite this. X squared minus 2/3 x. Then I'll leave a space. I'll let you finish that. And I'll let you finish D. Has anyone already finished C and D? Okay, the neighbor is done. Or set is problem. Check. And then go on to D. All ready? Let's go through C and make sure this one went well. James, how'd it go? Okay, well, let's see what you got.
Okay, so I divided both sides by 9.
Okay,
And I got x squared minus 6 times x minus 4 times 0.
cool.
And then I went to x squared minus 2x, 2/3 x plus 1/9 equals 1. And then I had to add 1/9 to the 4/9 wherever I added, that's actually what I was
Yeah, but before we move on, where that 1/9 come from?
the- the-
You start with the 2/3.
2/3 divided by, and then that would be 1/3. It's great.
Okay, 1/9, okay.
And there I got x minus 1/3 squared is 5/9. And then x minus 1/3 squared is 5/9, you move both sides.
Mhm.
X minus 1/3 is plus or minus 5/9. And then I would
Plus or minus,
5,
so you square root of square root of 5/9, okay.
I would put both sides.
Are we good with this? That was great. Really, really nice. But I'm seeing some hands up. Ryan, do you have a suggestion or a? Well,
Is this one out here correct? There's a four with this, that's one at that four. I one at the left, yeah, I don't like all time.
the rest okay? It's correct. Ivy, you know what you're looking for? Oh, what's the question?
From. When you look at here. What's the value of the nine? 9/9. And why do we divide by 9? But if you leave the position of 1, it's actually pretty.
I do want it just a little fix, a little tiny fix. So it's numerically correct, but. Mia, you know what I'm talking about? Yeah, we do have to do some, I'm looking for that square root of 5/9. Yeah, so you're talking about 1/3? Is that what you're talking about? Okay, I think you're on the right track. Ivy, do you know what I'm looking for here? Yeah, square root of 5/9, that's the same thing as square root of 5 over the square root of 9. And we know that the square root of 9, of course, is 3. So that's it. I mean, it's numerically correct, but I'm just gonna clean that up a little bit. Square root of 5 over 3. And I'm making sure that the radical is on top. Like, don't be sloppy with that. Don't bring it down accidentally over that fraction bar. Yes. Oh, common denominator. So right, this is 1 plus or minus root 5 all over 3. Seems good to me. Nice. Thanks for pointing that out. We had common denominators. Why not? Did you already finish D? I'll give you a moment. Same thing. You know, you know. Nancy? Last chance of the day. I can take a volunteer for this one. Someone who hasn't volunteered yet gets first choice. Anyone like to help? Looks like some people are still working. We'll go over this in about 30 seconds. We are running out of time. Any volunteers? Want to talk about it? Or you want to take it? You can if you like. You don't have to.
Okay, you divide everything by two,
Okay.
you know, the x squared plus 300. Into gap. Equals 4.
Over.
Over 2.
Okay, so two.
So I was wrong. Cool, so then you go in the middle, or in the gap, and you're at plus 9.
Are we good with that? 9/16? All right, in this case, just half of that 3 halves is equal to 9 3/4. Yeah, so 9/16.
I mean, you can rewrite that x plus 3/4.
But let's, Thank you. So you said we could write that as x plus 3.
3/4.
Okay,
Okay. And then I simplified it down here, and then 41, right?
okay. Nice. That was a quick fix.
And then you take the square root of both sides, so the x plus 3/4, and you root 41 over 4.
Just positive? Yeah, that's the one. It's root 41 over what?
4.
So it's square root of 41, right? Like this?
Yeah.
Over 4. Okay.
And then you subtract 3/4 from both sides. So x equals negative 3/4 plus minus 41. 41 over 4. And then you can solve it here.
I think we're done. We solved it. You can rewrite it if you want, because if that fractions coincidentally have a common denominator, you can put them together or leave them separate. But what do you think? Are we okay with this completely square stuff? Hope you like it. Factoring, yes? Quadratic? More fun to come next time in advanced algebra 2. Have a great day, folks. Thank you. Thank you today. Thank you. Oh, James, I'm just gonna put everything right. I have your one back. Hey, check this over to me right back. My pleasure.
I know.
That's not fun. Okay, I think that.